Welcome to Lesson 3C. In the previous lesson, we read in an article about water consumption and health, about daily water consumption. For simplicity's sake, we're going to put together recommendations for men and women, and let's just go with 11 cups of fluid per day. In this lesson, we will compare this goal with our class average using a measurement called standard deviation. Again, I've asked you all to have a glossary, flashcards, Google Docs, something where you're keeping track of the various and sundry words that we're looking at and their meanings and processes associated with those words. Here is another set of words, standard deviation, and we're going to talk about those today. The first question says, is our class average at, below, or above the goal of 11 cups per water per day? I'm going to go back to our dot plot from lesson 3B. We're going to look at it and apply the concepts for lesson 3C to our previous graph. And let me remind you that I'm using the data from our online class, and it's data that from students who sent their information in early. Your real data is not due until tonight. So we're using data that already has its flaws or issues, but I always think it's exciting or interesting how we can still get some very good results, even from data that's not exactly the large amount of data that we would want, but we've got it, we can use it, and we can still learn about standard deviation. Here's the dot plot from our water consumption from our class. And the question in number 1 is, if 11 cups a day is the recommended intake, our class average, is it at or above or below? Our class average was about 6.8. And so the answer is we are below. One thing I like about this class and the lessons is it gives us a taste of different parts of mathematics, which I think are very interesting and very cool. Starting with, we're going to look at the standard deviation, that it is a measure of spread for continuous data. Also, by the end of this lesson, we'll be able to use the standard deviation to interpret the spread of data, and in our case, it's going to be our water consumption. And then we're going to calculate percentage that's going to be in the graph region. Moving on to question 2, using the averages for each student in the class. Remember the averages. We first used all pieces of data, all 10 pieces, and plotted those on our dot plot. Then we went back and calculated each student's average and then graphed those. And those created a much tighter dot plot. So they're asking us to use the averages for each student. And then use a spreadsheet or website to calculate the mean. I've got all of this data, so I've got to hand the data to you. The mean of all the averages comes out to be around 6.8 or 6 8/10. When I calculate this thing called the standard deviation using Excel, I end up getting 4.1. The next question asking how many of the sample means are in the data set and how many students brought their data. We're just going to use the data that I've pulled from your information, and we're going to go take these two numbers and put them on our dot plot. This is our class dot plot. To answer question 2, we already have that the mean of the sample means is 6 8/10. We have that the standard deviation of these sample means is 4 1/10. The only other question was how many sample means are in the data set. I have 9. We are using from 9 students. We're going to continue on and calculate for question 3. I put the screen back up here in case you want to take a screenshot of it or a picture of it or even print the screen to have something on which to write. We're about to manipulate standard deviation and the mean around this dot plot. So go ahead and take a picture of it, get some kind of printout of it, get something that you can work on so that this meaning of standard deviation will have more relevance. I think what we're about to look at is very interesting. It takes a normal curve. Uh-oh, don't have any drawing room there. It takes a normal curve, and we're about to look at regions. And that drawing is not good either. Let's try this one more time. We're going to look at a normal distribution. And we're going to look at where the mean is. And we're going to start looking at where we deviate from that mean. And hopefully the drawing will be better in just a minute. And we're going to look at how far we're going away from this mean, this mu. And we're going to notice, what if we go a standard deviation below and a standard deviation above? What if we go 2 standard deviations above or below? And then we'll look at, well, what happens and what kind of data do we have inside of 3 standard deviations above and below? But first, we need to look at some addition. So this first little worksheet that we're going to do on question 3, they ask us to take the mean, which is 6.8. And they want us to add in 1 standard deviation. The value of a standard deviation is 4.1. And so when we add those together, and I'll calculate as you calculate, 6.8, 6 and 8 tenths plus 4.1, I'm getting 10.9. Jot these numbers down because we're about to go put them, oh wow, we're about to go put them on our dot plot and look at the cool thing that happens with percentages of our data inside this idea called standard deviation. The next thing we need to look at is, let's take our mean again, take the mean again, but this time let's go up 2 standard deviations. Let's go away from it a 4.1 and go away another 4.1. Calculate those numbers, and I'm getting that that number is going to be, and I'll go ahead and change colors to try to help this visually, that number is going to be 15. And finally, we're going to take the mean and go 3 standard deviations. Take the mean, and let's go away, 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 or up, up, up. 3 standard deviations. Let's add in another deviation, and it looks like we're going to end up being at 19.1. Document these numbers. There's not a lot to start and stop here to say, you go do this. There's a lot of guided teaching in this lesson. But hang in there and let's go do the other side from the mean. Let's start back at the mean of 6.8, except now we're not going to add in deviations. We're going to go the other way and we're going to start subtracting them. So jotting down and or calculating the mean minus 1 deviation, I'm getting 2 and 7 tenths. Remember, we're going the other direction, so let's take off a standard deviation, take off another standard deviation, and we're at negative 1 and 4 tenths. And let's do this one more time. Starting back at the mean, take off a deviation, and looks like we're landing at a negative 5 and 5 tenths. Make sure you have all 6 of these numbers written down in your notes or take a screenshot. 1, 2, 3, 4, 5, 6. And let's move on to question 4. Question 4 states for us to mark the mean and each of the values from question 3 on the sample means dot plot. So I'm back at our water consumption, but I don't have the sample means on here. So let me take just a second to go ahead and get our sample means. We had a 10. That's not showing up very well. Let me change that. We had a 10, a 9, a 16, a 4, 6, 3, 2, and a 7. Our sample mean is 6.8, which is a roundish right here. This is where our mu is. They're asking us to mark each of the standard deviations. So trying to find something that's going to stick out here. Let's go ahead and go with green. And the first standard deviation we calculated a while ago is when we go up 1 standard deviation, we're at 10.9. Then we were at 15. And then we were way out here at 19.1. Let's mark the other standard deviations going to the left of the mean. we would be at 2.7, negative 1.4. Oh my, we'll just go up. Negative 1.4. We'll put that at 1, negative 2, and I'm going to run out of space real fast. We're going to go ahead and call this negative 5. We'll squeeze it in there. And 2 deviations away is at negative 1.4. And the other is at negative 5.5. So we'll put it way out here. And I'll go ahead and change those colors. Negative 1.4 and negative 5.5. So we now have our mean and all 6 standard deviations marked. And if we are talking a normal curve, the cool thing about this data is that when you start to look at sections, an interesting thing happens with the data. And I apologize that my lines are really, really wonky, and I hope this still has meaning and value for you. The first question on number 4 says, mark these, and then part A, count the number of values between -1 and +1 standard deviations. We have 1, 2, 3, 4, 5, 6, 7. We have 7 data averages between -1 and +1 standard deviations. It says what percent of the values are between, and then they're asking us to calculate the actual percentages. In our case, we have 7 of the 9 fall between plus and -1, which puts us at about 78%. The next question, part C, says what percent of the values are between +2 and -2 standard deviations. And in that case, we have 1, 2, 3, 4, 5, 6, 7, 8, 9. So between +2 and -2, we have 100% of our data values. And that would be part C. Part D, what percent of the values are between -3 and +3 standard deviations. And again, all of our data values are there. Data is messy, but we're using our water consumption to talk about standard deviation. You have this on recording. You can start it and stop it and keep looking at this, but I want to keep going to question 5 and look at a definition for standard deviations. Keep in mind that our plus and -1, we were at 78, and we're about to find out that normal or standard is about 68. So we're not too far off. Okay, so maybe we are. And then we're going to find out in just a second that plus and -2 standard deviations is going to be about 95%, which we're not horribly off, except, well, no, except we're close. And then the final plus and -3, it's going to be 99.7% of the data. So looking more below part or question 5, looking at the standard deviations, this is what we were just talking about. Here is mu. Here's +1 standard deviation, which is a little sigma, and here's -1 standard deviation. The number you need to focus on, concentrate, memorize is that when we are between 1 standard deviation on either side of the mean, about 68% of our data will fall in that region. Down here, we've gone over 2 standard deviations and gone down 2 standard deviations. And so we have about 4 sections in here. And about 95% of our data should fall within that region, messy or not. And we were close-ish, we got to 100. And then finally, 3 standard deviations going up, 3 standard deviations, or going down 3 standard deviations. About 99.7% of our data will fall in these regions. This information may be confusing, but hang in here. And we're going to look at question 6, and I'm going to stay on this screen while we read through question 6. Looking at this visual, it still has familiar parts with mu, which is our mean, and our standard deviations going up and our standard deviations going down. I get all excited about these numbers and where the data falls. Don't know if you're feeling the same thrill and excitement that I am, but we're moving on to question 6. It says, on your paper, draw vertical lines through each of the standard deviations, and then they're going to ask us some questions. And then it mentions on part A, what percentage of data falls in section C? So never be afraid to mark on, draw, think, and between one standard deviation above and below the mean, we have a 68% of the data is going to fall in that region. Part A says, so what data falls in region C? If it's 68 across the two, we can take our 68, divide it by 2, and 34% of the data will fall in this region. And then it says, go ahead and do all of these for all of, I need to read it. Mark the leftmost region as A, B, and C. So we have a picture here. Then part B says, what percentage falls in section D? Well, if together they make up 68%, then part D is also going to be 34%. Part C says what percentage falls over here in B. I've got to do a little bit more mathematics because the part that falls, let me change colors. Between the two standard deviations, we're just playing around with these standard deviations. This piece has 95% of our data. Well, if we're just looking for the part in B, then we need to get our 95% and subtract the 68% because we're just trying to find out this little piece here. And I bet they're about to ask us about this little piece here. And grab your calculator. Just a reminder, scientific calculators are what we're using in this class, not graphers, not phones. This puts us at 27%, but that's 27% between parts B and E. So we need to divide this by 2, and we're going to get about, and that's just, I just multiplied by 2. Let's try that again. If we divide by 2, then what we have to split between the two is going to be over here, we get 13.5%, and over here we're going to get 13.5% for these regions. Finally, looking down at part D, it says, then what's going to be left for A and F? Again, we're just playing around with our numbers, and between A and F, or for A and F, we have to go all the way back to -3 standard deviations and a +3 standard deviations. And remember, and they're just getting this to play around with these numbers, 99%, 0.7% of our data falls under this region. If that is the case, we need to take out everything else, the 99.7. We need to take out this 95% that's in the middle of everything, and that leaves us with 4.7% of the data, but it's shared between sections A and F. So we'll need to divide it by 2 and get about-ish. Go ahead and punch in 4.7 divided by 2, and it's giving us that about 2 3/35% of the data will fall in region F and region A. I want to go ahead and take a second to add up all of these percentages. I want to add up 2.35. I'm starting over here, and then I'm going to grab our add 13.5, add in our 34, add in 34, add in 13.5, and add in our 2.35. And what should they add up to be? Since they're falling under 3 standard deviations, they should, and they do, add up to 99.7%. This whole lesson, we've been talking about standard deviations. We have played with them with our water consumption data. Then we've looked at the regions and what percentages fall under each region. Now we're going to do a practical application, starting with number 7. In a normally distributed data set, there are 500 values. We had 9, they've got 500. And they ask how many values will be between plus and minus 1 standard deviations of the mean. And so I like drawing a quick sketch. If this is our standard deviation of data, they're asking about how much is going to fall between plus and minus plus or minus 1 standard deviations of the mean. That's 68% of the data. And if we have 500 values within that region, then we're going to find out what's 68% of 500. Grab your calculator. Let's do a quick calculation. And we get that 340 values are going to fall within the region that is plus and minus 1 standard deviations from the mean. We'll keep going. The graph illustrates that 99% of the 0.7% of the data is expected to fall between plus or minus 3 standard deviations of the mean. Again, we have a normal distribution data set. It still has 500 values. And then the question switches on us just a little bit and says, how many values will be more than 3 standard deviations away from the mean? Again, I like to draw, hopefully not so crooked. But when I draw my normal distribution, when I draw the normal distribution, 1, 2, 3, 1, 2, 3 standard deviations away from the mean, they don't want to know how many data values are contained underneath those curves. They're asking how many are going to be more than 3 standard deviations away. So if this is the minus 3 and plus 3, we're looking at how much or how many data pieces are in the exterior, the extremes. If this region under here for 3 standard deviations is 99.7%, let's find out what we get if we remove that part and we're just left over with those extremes. So you can punch in, I will punch in with you, that when we calculate what's left over, we get 0.3%. So just like we did on number 7, what exactly is 0.3% of 500? Remember, we have to move our decimal over and do our calculation. On your calculator, let's do 0.003 times 500. How many data pieces are beyond plus or minus 3 standard deviations? And we're getting that there are just 1.5 data pieces. This lesson is now over. When this is a lesson, I don't even know where we are. This is lesson 3C. This lesson is over. You need to look at your calendar to see if there are more lessons you need to do for this week's assignments. Bye-bye.